Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to start with the MSQ questions of the JAM 2024 chemistry paper. What is the meaning of MSQ? Multiple select questions. That means more than one or more than one options can be correct. Okay, this is question 31. The suitable synthetic route or routes for the following transformation is. So what we have to do is reactant is given. Okay, this is, let's say, reactant. Okay, this reactant is given and product is also given. We have to find out all the four options are given with different reagents. We have to identify which all of the following reagents can be used for the given reaction. Okay, so let us start with the first one. Okay, so I'll draw the reactant first. Okay, here we have OH. Okay, below the plane there is hydrogen. So we are starting with option A. Okay, we'll see all the options. First one is TSCl and pyridine. Okay, pyridine and tosyl chloride. What is tosyl chloride? Okay, tosyl is this. Toluene sulfonyl. Okay, para toluene sulfonyl chloride. This is what? This is TSCl. This is the tosyl group. Okay, tosyl means this is toluene plus sulfonic acid derivative, that is having chloride similar to acid chloride. Okay, that is TSCl. Okay, so what will happen is the first step is pyridine is what? It is a base. It is a good base. So what does pyridine do? This is the structure of pyridine. Okay, it has this lone pair which can abstract acidic protons. So it will abstract this hydrogen and will get an alkoxide O minus. Okay, O minus, and this will undergo substitution reaction. Okay, this will attack this tosyl group and Cl will go away as a good living group. So what we have done basically here is we have converted alcohol, which was a bad living group, into a good living group. Okay, O. Okay, S double bond O, S double bond O. Okay, para position there is CH3. So this is basically what? TS group, OTS. Okay, this is the tosyl group. Okay, below the plane there is hydrogen. So if I want to draw arrows like this, it would be something like this. It will attack here, this will go here, and this will open up, and Cl will go away as a good living group. Okay, so this is the first step. What will happen next? Next is reaction with Ki. Ki means it has K plus and I minus. So again there will be a substitution reaction that is going to take place. Okay, so what will happen? I minus will attack from the opposite side. Okay, and OTS is a good living group. It will attack here, and OTS is a good living group because the negative charge is stabilized by resonance with the two sulfur oxygen double bond groups. Okay, via resonance. So it is a good living group. Okay, so what we will get is a CH2I. Okay, but with the opposite stereochemistry. Okay, SN2 reaction. Okay, so basically what happens is OTS group is now replaced with a iodine. Okay, stereochemistry here it's okay, OTS is replaced by iodine, and what is the next step? Next step is you are adding MgEt2O. So this will form a Grignard reagent. CH2 Mgi hydrogen. And then what is the next step? You are reacting it with carbon dioxide. Okay, so this is what? This is CH2 minus Mg plus. So this will attack the electron deficient carbonyl carbon. This will open up, and after you add aqueous HCl, okay, that is the fourth reagent. Fifth reagent, what you will get is you will get alcohol. you will get carboxylic acid, sorry, CH2, C double bond O minus. Okay, this will pick up H plus from HCl, and it after workup it will become OH. Okay, and below the plane we have hydrogen. So you can see we have got this reagent. So what we did first pyridine is a strong base, so it will abstract acidic proton from OH. Then this O minus will undergo substitution reaction with tosyl chloride. We get OTS group. Then iodine will undergo SN2 reaction. OTS will go away as a good leaving group. We get iodine, that is OTS is substituted by iodine. Then this alkyl iodide will form Grignard reagent on reaction with magnesium in presence of Et2O diethyl ether, that is what? A solvent. Okay, then the Grignard reagent will undergo nucleophilic addition with carbon dioxide. Okay, and we get, after workup we get the final product. So option A is what? Option A is correct. Okay, so option A is one of the answers. Okay, now let us see the second one. Again, I will draw this reactant OH. Below the plane there is hydrogen. Okay, the first step is again same as the first, as option 1, pyridine and TSCl. So I will directly draw the product as we had seen the mechanism just now. OH is converted to OTS. Okay, this is which one? This is the first reagent. Second is, now we are reacting it with KCN. Okay, instead of Ki, we are now reacting it with KCN. So what will happen? CN is a good nucleophile. It will replace OTS group. So what we will get? Cyanide. Below the plane there is hydrogen. Now what we are doing is, we are reacting it with concentrated aqueous NaOH. Okay, reflux. And the last step is workup. So what will happen here is, cyanide undergoes hydrolysis to form what? To form carboxylic acid. So first it will form this carboxylate ion, okay, sodium carboxylate, and then after I add the fourth step, that is the aqueous workup, HCl, O minus will pick up H plus ion from HCl, okay, and it will form what? The final product, that is carboxylic acid. CH2 C double bond O OH. Below the plane I have hydrogen. So this is another, again we have got the product. So second option is also correct. Okay, so now what we can do, okay, I'll erase this. Okay, then we'll go for the third option. Okay, let me erase this completely. Okay, now we are going for the third option. Option C. Okay, again I will draw the reactant first. CH2OH. Below the plane there is hydrogen. So first step is what we have done is oxidation. The first step is reaction with CrO3, chromium trioxide, H2SO4. Okay, primary alcohol will get oxidized to form carboxylic acid. Okay, primary alcohol will be oxidized to carboxylic acid. Okay, then what is the next step? Reaction with SOCl2. Okay, what will SOCl2 do? The carboxylic acid will be converted to acid chloride. Okay, second reagent. Now the third reagent is diazomethane. Okay, if I draw the structure of diazomethane, it is CHHNN, like this, CH2N2. Diazo means two nitrogen atoms, and then there is a lone pair. Okay, CH2 N2. This is the structure of diazomethane. Methane because it is only one carbon. There is only one carbon. So what will happen is this diazomethane, it will attack here. This will open up, we'll get O minus. Okay, and then that O minus will come back and Cl will be removed. So what we will get is, we'll get this C double bond O, CH2, N triple bond N plus and a lone pair. Okay, so then what is the next step? Next step is you react it with silver oxide and water. Silver oxide and water, what we will get is, what will happen is, the next step is, okay, this will act as a base. This will have, what it will do, it will form a negative charge on the carbon. At the same time, nitrogen will go away as a good leaving group. Okay, nitrogen is lost. Nitrogen gas is lost. And what we will get is, see, this is nitrogen gas is lost. So what will happen here, we'll get positive charge and this hydrogen is abstracted. So what we will get is, we will get a negative charge. So negative positive will neutralize and what will be left is 2 electrons on carbon atom. Okay, so finally what we will get here is, we will get a carbene. Okay, what we will get here is a carbene. C double bond O, CH, okay, carbon having lone pair. This is an intermediate, that is carbene. Now what will happen is, the next step is, there will be a rearrangement that is called Wolff rearrangement. Okay, so now what will happen is, how the Wolff rearrangement takes place, the R group on the other side will migrate here, lone pair will come here. What we will get is a 5-membered ring. Okay, then we have carbon double CH double bond C double bond O. This is which functional group? This is called ketene. Okay, then here ketene we will add water. Okay, this will attack here. This will open up and what we will get is a, I'll draw here above. Okay, so now what we have got is 5-membered ring, CH double bond C O minus. Then here water has attacked, positive charge. So this will abstract this proton and what we will get is OH. Okay, this is got OH and this has got its lone pair back. So this is also OH. Now this is in all. So what we can do, we can do tautomerism and we will get CH2, okay, C double bond O, OH. This is the final product. Okay, and this stereochemistry, it will be above the plane. Okay, the stereochemistry will be like this. Okay, CH2 COH, here below the plane there is hydrogen. So third option is also correct. And what is the name of this reaction? It is a name reaction. What is the name of this? Okay, I'll write here C. It is called as Arndt Eistert reaction. Okay, so this is the mechanism that I have shown to you, complete mechanism. But in exam, do we have a lot of time to write the complete mechanism? The answer is no. So what basically happens in an Arndt Eistert reaction is, you can remember there is diazomethane and then there is silver oxide with water. So what exactly happens is, there is one carboxylic acid, let's say CH3COOOH. What this Arndt Eistert reaction does is, it will increase one carbon. Okay, you saw here. Okay, before getting into the second step, after oxidation, what we had was, okay, here I'll draw it near to this final product. Okay, before getting the before starting this reaction, in the first step after oxidation, we had this carboxylic acid. Now in the final product, if you see, there is this one carbon that extra that is added. So that is the work of the Arndt Eistert reaction, to increase the carboxylic acid group by one carbon. That is it is a chain lengthening reaction. That is, chain length is increased by one carbon. Okay, so straight away you can draw the product. Okay, now let us see the last one. Option 4. Sorry, option D. Again, I will draw the reactant CH2OH. Below the plane there is hydrogen. The first step is again the same, CrO3 and H2SO4. Okay, what we will get is carboxylic acid. Below the plane there is hydrogen. And now what will happen is, we are adding diazomethane here. Okay, this is the structure of diazomethane we saw just now. Now what will happen is, this diazomethane, it will act as a base here. It will not act as a nucleophile, it will act as a base here. So it will abstract this acidic proton. Okay, and what we will get is CH2N2. Okay, what we will get is, we will get a C double bond O minus hydrogen, and CH2 minus has picked up hydrogen. So it has become CH3 and N2 remains as it is. Now nitrogen is a good leaving group. So what will happen? Now this O minus will undergo substitution reaction with this CH3N2. Okay, N2 will go away as a good leaving group, and finally what we will get is a ester, C double bond O CH3. Okay, do we want this product ester? No, we want a carboxylic acid. Okay, that is a different product. So option D is incorrect. A, B and C, all the three options are correct. Okay, A is correct, B is also correct, C is also correct. So the correct answer is A, B and C. Okay, so if you miss any one of the options, then you will not get any marks. Okay, there is no negative marking in MSQ. No negative marking in both the sections. Okay, in MSQ as well as no negative marking in MSQ as well as in NAT. But your answer has to be correct. Okay, or you have to select all the three options A, B and C. Okay, suppose you mark A and B, you missed C, incorrect. If you mark A and C, incorrect. If you mark only A, incorrect. Suppose you mark all the four A, B, C and D, again incorrect. So you have to select the correct option and all the correct option. Okay, so that is why MSQ becomes a little tricky. You have to mark all the correct answers or you will not get the credit. So I hope you have understood uh, all the reactions. Okay, the third one is a name reaction. As I told you, it is Arndt Eistert reaction. Arndt Eistert reaction. Okay, I hope you have understood the solution. Thank you.